Alrighty, so here we're looking at recurrence relations. So a recurrence relation is just a way of displaying that key information we have in a sequence. So remember, we've got a starting point and we've got the rule. Alright, so a recurrence relation is just that way of showing the pattern of the sequence. So a recurrence relation is made up of two parts. It's made up of a starting point and a rule. So our starting value is signified by the notation V0. So V0, when you see that, that means our initial term, our starting term. Right, Vm plus 1 is showing us our rule. Our next term is equal to Vn, which is our current term, plus or multiplied by whatever. So Vn plus 1 is our rule. It means our rule. Our next term is equal to, our current term is Vn. Alright, if we put that all together, we get our recurrence relation. So a recurrence relation is made up of our starting term and our rule. Alright, and we write it out like that. So, for example, let's take the sequence below. Alright, 10, 15, 20 can be written as the following two parts. Right, so 10, 15, 20, a starting term of 10. Starts with 10. And to obtain the next value, we add 5 to the current term and repeat the process. Right, more compact way of communicating it is in a recurrence relation. So the recurrence relation could be written like this. Our VO, our initial term, is equal to 10. Right, our next term, Vm plus 1, is equal to our current term plus 5. And that would be our recurrence relation right there. You see here that I've got a few notes. Here the variable Vn has been used, but V can be replaced by any letter of the alphabet. Alright, so we might have C0 equals 10, Cn plus 1 equals Cn plus 5. We'd have T0 equals 10, Tn plus 1 equals Tn plus 5. It does not matter. Alright, does not matter what variable is used. So V represents the sequence and N is the current term. Vn plus 1 means the next term of the sequence. Few key things. Alrighty, let's have a look at an example. So generating a sequence from a recurrence relation. Alright, write down the first 5 terms of the sequence defined by the recurrence relation, showing the values of the first 4 iterations. Alrighty, so we have got to show the values of the first 4 iterations. So remember, an iteration is the process of applying the rule. Alrighty, so we know that V0 is equal to 9. And the rule is the current term minus 4. Current term minus 4. Remember, Vn means the current term, and then our rule is to subtract 4. So V1 is going to be equal to the current term, right, minus 4. Now, our current term was V0, so 9 minus 4. V1 is going to be 5. Right, and the process between V0 and V1, that was our first iteration. Alright, let's find V2. Alright, V2 is equal to our current term minus 4. Current term is 5 minus 4. We're going to get 1. Alright, V3 is equal to our current term, which was 1. 1 minus 4, we get negative 3. Alright, so we've done one iteration to start there. Then that was our second, and that was our third. Alright, the third, second, first iteration. Alright, we've got to do one more. Let's find our fourth iteration. V4 is equal to Bn minus 4 again. And our current term was negative 3 minus 4. We get negative 7. Alright, and that's our fourth iteration. And we need to list the 5 terms. Alright, so the 5 terms are going to be our initial value of 9, and then each iteration after that. So we had 9, 5, 1, negative 3, negative 7. Right, there's 9, 5, 1, 3, -7. Lovely. So the next example is using a calculator to generate a sequence from a recurrence relation. I want you to go back and have a look at the video in the notes via this link here. Go back to the notes.